iPRSM. From design to audit to proactive management of change, iPRSM brings unprecedented accessibility, accuracy, and efficiency to pressure relief systems management. Welcome to an introduction to iPRSM. To introduce you to what iPRSM can do, we're going to demonstrate its audit capabilities in a sample ethylene facility, containing a unit with several protected systems and their related equipment, as shown in this simplified unit drawing. Then we're going to show how iPRSM guides us through mitigating the effects of any change to the facility across all affected protected systems. Because iPRSM is web-based, your plants are instantly at the fingertips of everyone on your team from anywhere in the world. From the iPRSM.com master menu, we access the iPRSM sample site we're going to use for this video. We enter our login ID and password, and pick the login link to get to the iPRSM sample main page. To our suite of existing plants, we'll add a new ethylene plant. We pick the Add a Plant link, fill in the plant name, and pick the Add Plant link to create the new plant and view it. From the plant view, we pick the Add Unit link to create our new ethylene unit. And when the unit view page appears, we enter the ethylene unit name. And here is one simplified P&ID drawing within our ethylene unit, to which we will now add a protected system. In the Protected System browser, we pick Add System, provide the E197 protected system name, and pick OK to add the system and view it. Here's a system sketch representing the protected system E197, which we will now assemble. First, we'll add a relief valve, ID PSV197. We pick Link Equipment to link the valve into this system. Since the valve has not yet been added to iPRSM, we pick Browse Add Equipment to access the equipment browser. From there, we pick Add New Equipment. Enter the PSV197 equipment ID, and pick OK to view the newly added equipment. We set the PSV197 equipment device type to Relief Valve. We select a manufacturer and enter a relief valve model number. Then select Use Parameters. This automatically fills in many of the PSV197 equipment values from the iPRSM equipment catalog. Note the trouble messages shown in red, prompting us to provide additional equipment information. We set the engineering code and enter the other process parameters for this valve, as shown here. Finally, we pick Evaluate Equipment to check that there are no longer any problems with this valve, as now indicated by the equipment status Evaluated. Next, we add the inlet and outlet piping and fittings for PSV197, using data entry techniques similar to those we've already demonstrated, producing results like those shown here. Returning to the Link Equipment page, we now find that the PSV197 valve we have added is available for linking. So we pick the plus icon to link the valve to the system, which takes us back to the Protected System view, where PSV197 is now shown as linked to the system as relief equipment. Using methods like those just illustrated, we add the other pieces of equipment that comprise the Protected System E197 and link them into their respective roles: relief equipment, protected equipment, overpressure sources, and ancillary equipment. Now we are going to add compound streams and thermodynamic flashes to determine the physical properties of the stream phases that are relevant to our E197 protected system. First, we add a new compound stream from our feedstock material, which we will call the feed mix stream. We set the number of compounds in this stream to 2, and then select those compounds and enter their relative composition. Next, we add a saturated liquid bubble point flash to this stream, as we will need the properties from this flash in order to compute the sizing and piping requirements of our system scenarios. We enter a name for the flash, select its type, and enter flash parameters. And then evaluate the flash to determine the physical properties of the phases involved in this flash. From here, we add any other flashes that will be needed for this compound stream. and any other streams and flashes that will be needed for this protected system. Now we are going to add the overpressure contingency scenarios that are relevant to this protected system. We add the first scenario and select its overpressure type, name extension, hazard type, and flow type. We select the CV100 control valve for this control valve failure scenario, which allows iPRSM to import parameter values from the CV100 equipment. Next, we pick the Select Fluid Phases link and designate stream, flash, and phase fluids for the scenario, which allows iPRSM to import values from the compound stream we recently created. Then we enter additional contingency scenario parameters, as shown here, and evaluate the scenario to determine its required area. Once we know the orifice area, we can move on to the piping losses, where we enter the relevant parameters and pick Update Piping Losses to determine the inlet pressure drop and outlet back pressure values. And once the piping losses are done, we can return to this scenario and sign it off, at which point the scenario status becomes checked, and we can return to the protected system. At this point, additional contingency scenarios that are relevant to this protected system could be added and signed off, as shown here. Now that we have all the equipment, streams, and scenarios in place, we can check the system to ensure that all the protecting devices are adequate and that all the devices that require protection are protected. We can see that the system checks out because the system status goes to System OK. Then we can sign off the system. And note that the system status goes to Checked. The techniques already shown in this video can be used to enter all the equipment, piping, fittings, systems, streams, flashes, scenarios, and piping losses involved in our unit. In this unit, we have these 3 protected systems. Once all the unit systems have been signed off, the unit can be signed off, as seen here. And once all the plant's units have been signed off, the plant can be signed off. And here is our completed plant. iPRSM's management of change features automatically detect all the effects of every change to the plant. To illustrate this, we return to our sample plant. Browse Equipment, and locate the control valve CV100. Now we'll see how iPRSM traces and mitigates the ramifications of a change to the CV factor. We access the equipment view for the control valve CV100. Note that the CV is linked to these 2 protected systems, both of which may be affected by a change to the control valve. We change the CV factor from 30 to 40. Back in our unit's protected systems browser, we see that the change to CV100 affected both the systems E197 and E207, so now we must go and recheck each of them. First, we pick the E207 link and check the system to see if everything is still okay. And it is, so we can simply sign off the system. Next, we go to the system E197 and pick Check System to see if this system is also okay under the CV100 change. But iPRSM tells us it is not okay because the PSV197 current relief area is now inadequate. So we return to the PSV197 equipment. And iPRSM's unique search catalog feature generates a list of relief devices that will satisfy the system's new requirements. From the list of adequate valves, we pick a model number link, and then pick Select and Done to select the larger H orifice area for PSV197. Now iPRSM informs us that the inlet piping does not fit the size of the inlet of our newly selected relief valve. So we return to this valve's piping and fittings, invoke the fittings editor, and pick the outlet diameter selector icon for the 3rd inlet fitting, the reducer. Here we change the reducer outlet diameter to 2 inches in order to match the inlet diameter of our new relief valve, and then select this new value. Note that iPRSM has adjusted all the piping downstream from the reducer to match the new 2-inch diameter, and that the trouble message regarding the valve mismatch no longer appears. Returning to the E197 system view, we can again check the system to see that all its relief valves are adequate and that all the equipment requiring protection is protected. And it is, so the status goes to System OK, and we can sign off the system. And the status goes to Checked. Back in the Protected Systems browser, we see that all our unit systems are checked. Our unit is checked. Our plant is checked. And the effects of the CV100 change have been effortlessly mitigated. This was only an introduction to what iPRSM can do. Alone among pressure safety management programs, iPRSM delivers a fully integrated solution that also manages plant design and auditing, thermodynamic properties, distillation columns, equipment findings and deficiencies, system revision control, extensive printable reports, equipment libraries and worksheet revisions, a document library for uploading and storing documents, and diagrams related to systems and equipment, and the unique ability to produce impact analysis reports that identify protected systems that may not be compliant due to changed codes or standards in minutes rather than months, and at a fraction of the traditional cost. From design to audit to proactive management of change, iPRSM brings unprecedented accessibility, accuracy, and efficiency to pressure relief systems management. Brought to you by Curtiss-Wright Flow Control and Ferris Engineering.